Hey everybody, we made it to week 2. So this is going to be our first lesson, which is going to be on polynomial graph behavior. A lot of review, but it'll help us and set it up for our second lesson, which is going to be on sign analysis. Sounds scary, but it's really not. I'm going to show you how to do that, no worries. So let's start with the review terms, solutions. They're called roots, x-intercepts, and zeros. So remember the roots, when we have it in factored form, they would be the binomials. So we would end up with x minus 2, and our root would end up being, our x-intercept would end up being positive 2 for the x value and 0 for our y value. And then for our zeros, x would just equal positive 2. All three of those are the same thing, even though their solutions are kind of formatted a little differently, and that's okay. Solutions, when we're talking about a polynomial, is if we had a polynomial or something with many curves, some crazy thing like that, we would end up with our solutions wherever it crosses the x-axis. That's what we're looking for today. Okay, I do not want you to focus on anything as far as how far up or how far down. That'll be another lesson when we kind of look to see if we can find the relative max or the relative min, okay? So we're going to look at quadratic properties and kind of take one step back and remember what we talked about as far as finding solutions for that. There are 3 different outcomes we could have. One, our quadratic can pass the x-axis twice, and we would end up having 2 solutions at x equals 0 and 4, okay? So 2 real solutions. Now our quadratic could come down and kind of touch or bounce off the x-axis, and we really only have 1 solution, but when we look at the factored form, notice how it's x minus 2 squared. So we really have 2 solutions, because we would set this equal to 0 twice, and x equals 2 twice, but that's redundant. We only need to write it once, because it's really only the same number twice. So it's going to come down, bounce, and come back up. Now instead of using the term bounce, because that's not mathematical vocabulary, it's tangent. Do you remember when you were in geometry and we were, when you learned about circles? And I'm going to move that over here. When you had a circle and you had a line that was tangent to that circle, it would approach the circle, touch the circle, and continue on at one point, 90 degrees from the center of the circle. That's exactly what this parabola is doing, as far as it's going to approach the x-axis and then touch it and go on up to infinity in the other direction. That is just touching it, so it is tangent, a line tangent to the parabola. Alright, so let's go ahead and take a look at the last one, which was we would have the parabola would approach the x-intercept, but before it even gets to the x-intercept, it starts turning and going off into the infinity direction, both positive and positive for the y. For x. And in this case, it's going to have no real solution, but we could find the imaginary solutions, but that's not what we're focusing on today. Alright, so we are going to focus on finding real solutions of polynomials. Now, so it kind of explains the special relationship between the quadratic's vertex and the x-axis, okay, and that's when it's tangent. And that's going to be a vocabulary word we're going to use with polynomials. Okay, so whenever you see a factored equation squared, that's going to be tangent to the graph, and that relationship is also going to happen in polynomials. Okay, so let's talk about linear functions. With linear functions, if it's a non-vertical line, it's going to cross the x-axis at one distinct spot. And notice how at the beginning, it's just a straight line. It crosses. So this is going to be a cross. With cubic functions, we're going to end up with how many solutions does r to the x equals x to the third half. Okay, and it's really just one solution right at 0. Okay, because we would take the cube root of both sides, and we'll do that later. Okay, notice how a cubic and a linear, they both cross the x-axis, but in this isn't the same as a linear. Okay, and this is actually called a point of inflection. So point of inflection, instead of rewriting that every single time, we're going to kind of abbreviate as POI. So right at x, I'm sorry, not x, right at the x-intercept, in a way, it would be a point of inflection. Later on in calculus, you're going to find the first derivative of this curve, and it's kind of cool because the first derivative is just really finding the slope at a particular point as you go along this graph. And so notice how it's going to be on this side as we approach 0, okay? But as we go past that point of inflection, it's going to continue to go on the other side. So you're going to end up finding the slope of the other side of the line. And that's the point of inflection, or the definition of what that is. Okay. Now, maybe teachers in the past have called it a wiggle. Kind of looks like a wiggly worm. So if you see anything like that on a graph, that is going to end up being a cubic function, or to the third power, and that's a point of inflection. Okay. So I'm going to start another video for lesson 2. Hope you have a wonderful day. If you have any questions, please come see me during Zoom tutoring times, or email me, text me. Lots of ways you can get in contact with us. Have a good day, guys. Bye.